second to last lecture before the final exam. Today I have planned for us to, in class, actually do a practice question. So I've already posted the code for it, but we'll do it at the end of class. First, I wanted to talk a little bit about Lambdas and functional programming. Hopefully it'll be fun. Any course logistical questions? There's one really good one on Piazza about where to submit the final project report. I made a Canvas submission box for it, but I actually think I want you instead to submit to Gradescope. So I'll make a Gradescope submission box. So the final project report is due on Friday, and it should be the summary of your entire team's contributions. Every team member at minimum must give one full page summarizing what they've accomplished. Also, it should include maybe just a really cool feature that you're proud of. If you made an extra feature, then definitely talk about it. If you spent hours debugging something and you learned all these cool debugging strategies, like you used GDB for the first time, now you're an expert, and it ended up being like the super tiny bug where, like, I don't know, it was signed versus unsigned or something, definitely write about that. The contributions, we just want to see that everyone got the learning outcomes out of this course. Any other logistical questions? Yeah, question. Yes, the check-ins, you can kind of just consider them kind of just free points. So yeah, the check-ins are, as long as you've done the check-ins on time, then you get those points. The report, though, if we see like, oh, maybe they wrote a page and it was all ChatGPT and actually we checked their contributions and it looks like they did nothing, they might get a 0 on the report. Someone else, maybe on that exact same team, maybe they worked extremely hard, came to office hours regularly, they would get 100%, maybe even if their team doesn't have like full, like a bunch of extra features in it. So we are grading the final project report very partially because it is potentially like, I don't know, it's wrapping up like everything that you've accomplished in the quarter. Yeah, feel free to reach out to any of the TAs to like learn exactly where you are already standing. Follow up. Yeah. Yes. We're checking both, right? We have the code on one side, we have the report on the other side, and all the TAs, we're going to be in a big meeting, and we're going to like spend like 3 hours having a conversation about every single student in this class and coming up with some grade for everyone. Yeah. No, we're just looking at main. Every bit of code should be in main unless it is explicitly mentioned for some big reason. Maybe the big reason is that you were working really hard on a feature and it's like not quite ready, like it's mostly ready, but it's not ready to be on main. But I don't want to see like every person have a completely different branch and also like the branches are weirdly named. It must be like maybe maximum you have 2 branches, one that is main and then one that is, oh, sorry, like we were trying to finish this last little feature. We don't want it to be like lost, but like that's all. Yeah, everything should be on main. Yeah. Sure. So yeah, right. So if you contributed really hard and then all of your work kind of got lost on a branch that was not pulled into main, then that is fine. You can just mention that in your contributions section. But I mean, there would need to be like a good reason why that was not put into main. If the reason is that maybe your code was not useful because it wasn't following the description of the project and was kind of unusable, then that doesn't really count for anything. It's like we don't want to just see like you working on it. We want to see you like achieving something, like learning, writing good, high quality code. Yeah, sure. Yeah, question.
Just to confirm, did you want the summary to be a page or did you want the feature included?
Summary, so each person in your team must at least write one page. That means, like, there can be some amount of overlap. You can have, like, each person talk about the one feature they did, if that's how you want to structure it. Minimum, every person must write one full page. It can be in any kind of format. You could just write, like, one page is all, like, the bullet points, and then everyone takes a page later on or something. Yeah, every person must write a full page. Yeah. Okay. Yeah, any other questions? Okay. Are the final projects, or are the final features coming along? Anyone got anything, like, really exciting? Yeah. I'm seeing, like, there's some people posting some really good Piazza posts that are like, oh, like, how does this work as a feature? And then I look at it, it's like, wow, this is incredible. So I'm really impressed by what's going on this quarter. Don't disappoint me. Okay, good. So Lambdas, that is what I wanted to talk about for a little bit today. Yeah, then we'll transition. Cool. So first, I want to demonstrate a potentially new feature of C++ that maybe you've never seen before. And this is, sorry, let me just finish this. Okay, and that is the std for each function. Oops. Okay, and potentially something that you could do here is maybe it's turning on. Okay. Yeah. Okay, fantastic. Good. Yes, so here I just have this vector, and I'm going to use the for each function on it. And here, so I can put in numbers. It takes in an iterator, so we can say go between numbers.begin and numbers.end. Okay, and then the way that you use this is you can put in any sort of function right here. So maybe we can have some sort of void print function that takes in an int and do std cout and std end line print. Okay, so we pass the function into there. Okay. And I need algorithm. All right, sure, cool. Potentially a new way to run a loop could be useful, right? Yeah, passing in this function in right here. Well, something that is a little bit annoying, though, is that this whole function that we need to declare is kind of just boilerplate. Like if we look at it, it's void. It's like kind of implied here. We're not using the return. And then here it's like, okay, we're printing. It's like, well, yeah, also don't really need that. It's like very clear what this function is doing. Int n, like, okay, sure, yeah, we should probably declare what it takes in. But like this is kind of the most important part. It's just this. So it'd be nice if somehow we could just take this implementation and just kind of like drop it in there, right? Wouldn't that be nice? Right? Yeah. Well, it turns out that we can basically do exactly that. And the way that we do that is with a new C++ feature called a lambda. And the way that you use lambdas is first you do these square brackets right here, and then you do round parentheses, and then you specify whatever it takes in. So here we can say it takes in int n, and now this numbers.begin and numbers.end, this expects a function with one input like argument. So okay, so it's specifying the input argument, and then this is what this function like is implemented as. So then we can go and run this. So cd into lambdas. Okay. Cool. There we go. So we've just printed out an array. Okay. Maybe this is useful because also we probably could have just done like whatever 4 into I like to n or something, right? Sure. Cool. Now that we've just unlocked this like lambda feature, well, maybe now we want just a function that will, and also note like we no longer needed this whole boilerplate right here. So like this is all gone. So that's kind of the benefit of lambdas, of this notation right here, the square bracket and then round parentheses and then curly braces, is it allows you to initialize a function like in line. Like within side of a function, you can declare another function. And like for all intents and purposes, this is just an object right here. So actually this right here, we could probably just say like we could say print is equal to this thing. And this is now an object that we can just pass into here. Pretty sick. Yeah, so all lambdas are they are just a way of creating a function in line within like another function or treating it as an object. And it helps kind of remove some of the boilerplate. And the potential reasons why you might need this is if you are switching to a more functional style of programming. Remember, so functional programming is the idea that kind of everything that you do is all revolving around functions. And it also requires that every function, remember, must be non-mutable. So it should not mutate any of any existing memory. The idea with a function is it returns one value and then it fills that value immediately, so it does not edit anything. And then also there are no side effects. So by running some sort of function, it doesn't edit the external environment. And what that enables you to do is you can actually write any code that you want using like entirely functions, and now you don't need to make classes and things. And so it's an entirely different kind of style of thinking. And lambdas are great because now it means that you can write functions faster because there's just less keystrokes and it's clearer to look at. Cool. So like, I don't know, for example, like if we wanted to like reuse this right here, we could go and we could wrap this inside of a function if we wanted. So okay, look at this and think to yourself, okay, what do you imagine the new notation would be if we wanted to put this inside of a lambda? Okay, so what do we need to do to put this inside of a lambda? Okay, what is needed? How do we turn this into a lambda? Yeah? Right, sure, perfect. So square brackets, and then inside of parentheses, yeah, we could put this like vector numbers. If we wanted, we could probably also do like auto numbers. If we wanted, we could say auto x equals this now, sure. And then how could we then go and call x? What would that look like? How do we call this? Oops, I actually also need to put braces. Okay, how do I call this? It's called just like any normal function. So I've declared this like function right here. Yeah, exactly. X parentheses numbers. Okay, sure. And now we can go and run this. And we are getting an error. And the error, though, is that I'm assuming it's going to say, like, oh, print does not exist. It doesn't know what print is. And that's because lambdas by default don't grab what is outside of their scope. But here we can see print is actually declared, outside the scope. So therefore, what we need to do is actually utilize these first square brackets. And these square brackets, these allow you to pass in whatever global variables you need to access or that you want to access. So what we can say is just do something like this, I believe. It's still getting an error. Hopefully that's fine. I'm missing. There we go. Yeah. So there we go. So now we can see that we are successfully grabbing print because now we are referencing print. Notice that I'm putting this ampersand here. This means that we are grabbing it by reference. If we want, I believe we can also do this, and this will now grab it by value. And effectively what this will do is it will now copy this print object. Yeah, cool. And also note, this lambda expression, this is created at runtime. If we wanted, we could add a bunch of different lambdas to a data structure, and then we could go run through the data structure and deal with each one of these functions later. This is created at runtime, which is very different from functions. Usually you think of functions as being stored in just the text section of your program. Yeah, pretty cool. Okay, so another thing that you can do, just kind of dumping some more notation on you, if you didn't want to specify every single global variable that you wanted it to access, and instead you just want to say access everything, instead you could just put a equals sign right here. This equals sign says just grab everything. If you want, you could also do an ampersand, and that says grab everything by reference. So this will still work. There we go. Cool. Okay. Very fun. So that is the notation for lambdas. There is one final example that I wanted to walk through. So now, yes, let's do that. Yeah, cool. So if you remember, an example that we've already done before was sorting, but specifically sorting in a specific, using a specific comparison function. So, okay, off the top of their head, does anyone remember how to sort a vector backwards in C++? This was a quiz question at one point, so it would be fair game on the final. It's very reasonable question. Oh, how do you sort a vector backwards? Okay, anyone remember? Just ask ChatGPT, right? That could work. Yeah. Right. Do you remember what the vector sort function is called? What was that? Yes, sort, but it comes. How would you call this sort function? Do you remember? Ooh, not quite. I think you can do that in Python. In C++, you do std : sort. This is just, I don't know. That's how you sort things. And then what we do inside of this is we do this numbers.begin, numbers.end. Okay, and then as you said, then we go we can put this optional comparison function right here. And usually what you do is you'd create a whole nother function, and the function would probably be called compare, and then you would have A is less than B. But instead, to save some keystrokes, maybe we could do it using a lambda. So okay, finish this. Look at this, turn to the person next to you. I know it seems like we're sitting really far away from each other, but maybe scoot a little closer to someone. What would you put inside of here in order to now sort the array backwards using a lambda? Okay, take like a minute on that. I'm going to go grab some water. Back on now. Hello? Fix? Okay, whoops. Okay, hopefully. Anyways, yes, okay, so there's a bunch of functions in C++ that work on vectors. Yeah, one of them sorts, one of them for each. But kind of the issue with at least like sort, right, is sort a pure function? Yes, sort is actually not a pure function because it modifies the value that it's passed in, right? So, but there are a whole collection of pure functions that all work on arrays. And one of them is something called, actually, give me just a second. Sorry about this. I lost my notes. Okay. Okay, good. So, good. Okay. Yes. Okay. It's called std any of. And what any of will do is it will look through the array and it will find the first value which is true. So what we could potentially do is we could take this like numbers dot begin or something and numbers dot end. Okay, and then we could, if we wanted, we could check like if any of the values are equal to 5. So we could say brackets, and then we could say int value, because we go and we pass in one, like for each value, it's kind of the same thing as for each. For every element in numbers, we go and we can pass it into this lambda right here. And then if we want, we could say like, oh, return, like, I don't know, equals 5. So what this will do is it will return, this will produce a Boolean. So bool, like, any R5. So this will produce a Boolean, any R5, if any of the elements inside of numbers satisfies this lambda, which is that val equals 5. Sure, cool. So we can go and print this out now if we want. And yeah, a little bit hard to see, but you can see like it finished printing the function, or finished printing the array right here. Then here it's printing out that any of them are 5. Because yeah, we can see that there is an index that is equal to 5. But if we now did like 6, then now we should see it print out 0. Yeah. Okay, question. So is any of a pure function? Well, it can be, right? It can be only if what? Okay. Yeah, when can any of be pure? It's pure most of the time, right? When can it not be pure? Okay. What if I did like numbers or something? And then did something crazy to this. Like, let's say I did, like, numbers dot, I don't know, push back. Okay. Is this now a pure function? No, this is not, right? Because we're modifying this. Yeah. So any of is a pure function only if we pass in a pure function. So, yeah, pure functions, they kind of, yeah, whatever, require other pure functions whenever they work off of each other. But yeah, this any of function is like extremely popular. It's extremely popular in like Python. I'm certain that you've seen it in Python. There's an any function. There are all sorts of functions, yeah, that work on large arrays like this. And that is, in my opinion, the most common time where I see lambdas, because yeah, they just want like software engineers just want like a cleaner way of creating functions using less boilerplate, because they can just put the function declaration just like in line like this. Yeah, kind of cool. Okay, was there a question? Question? Yeah. Exactly, yeah. Pure functions are things that don't change anything back in the main function, and also they will always return the same value no matter what, like no matter how many times they're called. Yeah. Like we could potentially have something here that would be like, oh, if we are currently reading the last value of numbers, then go and add a 6 or something. In that case, then on the next time that you would run this function, then now we would return true, even though the first time we would return false. So yes, that would also mean that it's not a pure function. So a pure function cannot modify anything, and it must always be deterministic, no matter what day of the week, no matter what state your program is in, a pure function will always return the same value, given the same input. Okay. Any final questions on lambdas? Okay. Lambdas, yeah, super popular. I actually have, yeah, okay. Anyone spend time using the GitHub search feature since the last time I pulled it up? Anyone pulled up anything interesting? Okay, yeah, like you got to spend like hours in this. This is good stuff right here. For example, we could, if we want, find a bunch of lambdas. So we could just search C++ code. It's like, oh, you know what? Like Ethan's full of it. Like, you know what? I doubt I'm even going to find a single instance of a lambda anywhere. Or it could be like, oh, you know, I think lambdas are cool. Let me find some real-world examples of lambdas being used. So, okay, in this case, we can search for a lambda, and we'll use a regex. Okay, anyone use regexes? Okay. So regexes, so it's a regular expression. It is just an expression that can be used to match a substring inside of a larger string. So actually, I have this already open. So here is this website. It's called CSE111. So this right here would be considered the regular expression. And then this right here would be some string that we are searching within. So here we can see, like, this is a valid starting of a lambda. Here I put in this letter A, so this would not be a valid starting of a lambda. But then each one of these kind of characters up here, which kind of looks crazy, is grabbing, like, it's trying to, like, create a very specific filter to, like, grab a substring. So what GitHub allows is you can build your own, regexes, and you can search using the regex. So, okay. In order to search for lambdas, we can create a regex. And so first I will grab the left parenthesis. Then I can grab just like whatever characters are in there. So this will just grab like whatever. Then I can grab the closing parentheses. There we go, I've got that first bit. Then we can go and grab any like white space that is in between. And we can do this to grab 0 or more white space. Then we can do this to grab the left parenthesis, and then we can grab just whatever characters we want. Then we can grab the right parenthesis, and then grab any white space. So you can see, like here, as with every like little bit that I'm typing in, you can see that like the filter is becoming more specific, and then I can end it with this like brace right here. So now we can take this big long regex here, which will match to only like true lambdas. Now we can go and search for this. So there we go. And there we go. So we can see here's a few examples of regexes being used, of lambdas being used. You can see that there's roughly 5.5 instances of lambdas in C++ on all of GitHub. And if in your free time, you can read through all 5.5 million of these and report back to me. So cool. Sure. Regexes. Highly recommend learning them. I'm not going to talk about them any more in this class, but yeah, they're undoubtedly extremely useful. Cool. The final bit of class I now want to dedicate towards doing a practice question from the final from the last course offering. So on Canvas, I have already posted a tar file. It's called march12th.tar.gz. 3.12, whatever. So what you will all need to do right now is actually go and download that file, and then we're going to kind of work through it. First, I want to give everyone maybe like 5 minutes just to get it like downloaded. In the final exam setting, it's going to be fairly fast-paced and kind of stressful, so you might look at it now and be like, oh, this is an easy question. But like actually, most people did not get this question right the first course offering. So the point of this question is debugging and setting up a debugger. So I'll let you all work on it for like 3 minutes. So like time starts now, and then we'll reconvene. Yeah, there's no grading. It's technically optional, but highly, highly recommended. It will definitely prepare you for your exam a week from tomorrow. Yeah, question?
Have you fixed the link for the partners for the final?
I have not yet, no. That's on my to-do list, yeah. Okay, please go and download that. I'll set a quick timer. on now? Is it on? Okay. Wait, okay. I just want to quickly show you something else unrelated to this course. So something that I was doing recently is I'm planning on going on a big like international trip this summer, and I'm splitting it with like 5 people, and there's gonna be like moments where like some person's gonna be in the country, and then we're gonna meet up with someone else. And like planning flights was a huge pain, but what I found is that you can actually use like APIs online, and you can grab flight information. And then what I did is I like wrote this like big script that took in all these possible flight configurations and found the optimal like start day for like every single person, plus or minus like 3 days. And I just want to show you. So here is the like graph that I generated, and you can see. So here's like everyone's summed price. Here's the total duration of like the flights, and here's every single possible flight. Like of course up here it would be really expensive and really long. So you want to get like as far down into this region as possible. Pretty sick. I just sent it to my friends, and unfortunately 2 of them just bailed. So now it's like much easier to plan. But anyways, I'm just really proud of this. Yeah. Exactly, right. Yeah, right. But also, I mean, it was kind of hard for me to even know because, yeah, there were like, there's millions of options. So it's like, oh, you know. Anyways, yeah, I apologize. That's the reason why I haven't published the lecture recordings as I was working on this. So there we go. Now you know. But if any of you need help planning your international trips, I have a great code base that I can share with you. So cool. Okay. So it was written in Python, by the way, not C++. So it's maybe blasphemous, but okay. So anyone have any luck? Anyone find any issues? What's the first issue that we all ran into with this? Anyone compile it yet? Compile. Wait, show of hands. Have you tried compiling it yet? Okay, good. What is the issue when you tried to run it? Say it. Okay, unfortunate. Okay, let's go and test that really quick. I believe you, but debugging, we can just run this make file. There we go. /app. Okay, segfault. How do you find the issue in a segfault? I heard someone say it. Wait. Yeah, GDB backtrace. Okay, that will tell us exactly like at what point our program is at. So if we want to now run this using GDB, so there's a couple options, right? The first option is if we wanted to just use it, using command line, like no VS Code, what flag would we need to add to now be able to run this using GDB? What would it? -G, exactly, yeah. So let's go and just add that, so -G, and I can go and remove app and then remake it. Okay, and so now we can do GDB app, and I'll just go try again. Okay, there we go, and now we can go and run it, except it's not working. There we go. Okay, cool. So good. So we just ran it, and we successfully found this segfault. So backtrace, right? So if we type in backtrace, I don't know why my cursor is not showing up, but I just typed in backtrace. Well, here we go. So we can see all the different functions that were run in order to get us to this segfault. So you can see first it ran main, then it ran run, then it ran display, and then it ran OStream, and then it's segfault. Honestly, yeah, it looks like the segfault happened in the OStream almost. So that's, yeah, a little bit concerning. And we could spend more time on this. But first, let's instead open it using the like VS Code GUI. So yeah, let's assume like, high stress situation. It's the final exam. It's a hot room. It's your last final of the week. You're just trying to get this over with. How do you enable the GUI for the debugger, the C++ debugger? Okay, what do we do? Okay, yeah? Yeah, so I would definitely do CMake. I think that's going to be the easiest thing. So okay, so we just need to go and create a CMake list for this. So okay, let's go and do this. So CMake lists.txt. Okay. Do we like writing CMake files from scratch. It's honestly kind of a pain. Well, if you remember, you actually have access to your final project. Like, you are allowed to use any code that you've written during your final project on this exam. So what I would probably recommend for you to do is just go into your like Banana emulator. For example, here is mine, and here is my big CMake file. And now I can just go and copy this. Oops. There we go. So I can copy this, and I can go and paste this in. And then I can just simplify it to only grab the things that I need. So I can probably get rid of all of this, get rid of all this. So this is basically all I need. For include directories, I should probably just include this debugging directory. And then for all the files, how many files do I need to compile here? How many do I need to pull into my executable? Yeah, it's just 3. It's just the .cpp files. So it's going to be probably app, and then main, and then menu. Oops. Okay, that is all the files. Okay, are we done with this? I guess we can change the name of the executable maybe to app. I think that was what it was called. Okay, are we done? Are we missing anything? I guess we could look back at our make file, but I think we're pretty good. It does say std17, so I guess we could change this to 17 as well if we wanted. Okay, so great. So now we've just created our CMake lists. Now we can go and run it with CMake. So you may need to reload your window in order to find the CMake file. So I'm just going to reload this. Okay. There we go. So now we have CMake. We can go and hit debug. Building, building, building. Okay. And success. Okay, cool. We have found the seg fault. And okay, it looks like the seg fault happened at this line. We can very clearly now see exactly what line this is on. So the first thing that I'm going to do is I'm going to check, well, what is app? Okay, so does app exist? So what we can do is look on our left-hand side, and we can maybe expand this out. And we can see, well, app, it does have some value here. So, okay, so this maybe has something. Well, yeah, and if we extend this out, well, actually, it looks like display stream, is this working? I don't know. Yeah, like what if we tried printing out app? Okay, what if we tried dereferencing it? Okay. Sure. Well, this is a little bit interesting. We'll take a look at this. So the menu, okay, so the menu takes in an app, right, and it fills out app. Like if we look at the menu, at the constructor, so you can see if we have one member right here, it's just app, okay? But actually, it looks like it's not actually filling out app here, right? It looks like the constructor is empty. Is that what we're seeing? Yeah. Oh, I hit F1 to pull up this dropdown, and then I type in reload. Cool. Yep. Yeah, great question. Okay, so how can we now properly initialize this app member? It's not a trick question. How do we initialize our app member? Remember, we have this app member right here. Sure, yeah. So we can do it in like an initializer list. So we could do : app like that. something like that. We could also just say like this app equals app, if you like that format instead. Okay, good. So sure, let's go and recompile this, see if that fixes anything. So we can go and run debug on this now. Going to take a second to compile. And oh, look at this. Actually, it looks like it might be working. We solved the segfault. Now let's see. So if I now hit the number 1 and select this, well, okay, well that doesn't look great. So okay, unfortunate. It looks like it ran into an infinite loop somewhere. So what we can do is we can step through and what the? Can we step out? Step out. What? Wait, why is this happening? Wait, what the heck? Okay, well, what if we hit play and then pause again? What the heck? This is not what was happening earlier. Well, that's okay. What if maybe instead of this, maybe we go and find where this message is happening, right? Because it says like, welcome to my app, and then it prints out everything. So let's go and search for this and see like maybe we can find where this is being printed. So okay, so this is being printed, this message, it is const expression title. So we can check wherever title is being printed. Okay, so notice I'm doing Control-Shift-F on the left-hand side to search in my entire project right here. So here we can see that it is being printed out right here. So we could add a breakpoint, and now we could go and run it until it reaches this breakpoint. There we go. Okay, so now we're out of the logger. Not sure why we're in that, but okay, so cool. Looks like this is properly being printed, but it looks like display probably is being printed like over and over and over. Like it looks like it's display, 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 display. So let's go and see where display is run. So what we can do in order to find where display is run is, so we could do like, step through. Then what we can do is step out. And this will step out of this function and show us, where display is run. So if I step out, then there we go. We can see that display was run right here. So okay, and actually, here's a while loop. So we can guess that there's probably an infinite loop here somewhere. So okay, so let's take a look. Tell the person next to you, where is the infinite loop? Because we have this break right here, I guess. And this continue. So maybe it should be working. Yeah. Oh, yeah. So this choice? Sure, okay, yeah. So what's happening is we have this while loop, and like it is, I guess down here, it is saying like enter your choice. So it is asking for you to enter your choice again, but for some reason it's never getting to this point. Yeah. Any ideas on why this is happening? Okay, yeah? Oh, yeah, actually, I think that it is what is happening. So if I do the next line, it looks like no matter what, display, we can step out again. Yeah, so continue is just always restarting. So actually, maybe we should leave this, we should get rid of this continue right here. So if we get rid of the continue, then now, in theory, we'll continue through, and then we'll ask for the choice again. Yeah, so let's now go and test this. Good stuff. And we can add a breakpoint here or something if we want. Okay, we can get rid of this breakpoint. We can run. And there we go. Okay, it says enter your choice. So we can give a choice. Maybe we can say option 1. Looks like option 1 should be the menu. So we can hit enter. Okay, good. So we have hit our breakpoint now, and we could step through And okay, it was option 1, and looks like it properly printed out. And then now it's saying, enter your choice again, and then it's asking for the choice again. So good. So then we can enter our choice. We could say option 2 now if we want. Okay, good. And now it's restarted, and it's saying like, oh, well, if the choice is, and oh yeah, first it does this, it says like, oh, log option 2, and then it says option 3, and it says option user selected exits. Well, actually, this doesn't look good. So it looks like, so we just selected 2, but now it's logging it for all of these. So okay, that's weird. So let's go and search for where this is. So if I search for this, okay, cool. So I can go and add a breakpoint here, and hit run. There we go. I can do option 2 again. Okay, run. So now we can see, yeah, so we're on this case. So it properly is now going to print out user option 2. And then when we step over, well, look what happens next. So then it goes and runs option 3. We step over again, and it runs option exit. Okay, so what is the solution here? Okay, cool. Yes? Yeah, exactly. So there's no breaks. So we just go and insert our breaks. Okay. Very good. And hopefully this works. Actually, I'm not going to run it with the debugger. I'm just going to run it. Let's see if we can kind of break it now. CD. Okay, good. So let's go and try option 1. Okay, looks like option 1, so user choice was 1, menu is 1, good. Option 2, okay, logs option 2, okay, option 3, this looks good. Option 4, exits. We could try it also, so if you remember, I guess I didn't go over the instructions, but if we were to look through the instructions first, what we would have seen is, so it says, so you are given a broken application, first read through the code, figure out what it's supposed to do, then debug everything, make minimal changes to the source code, only a few lines should be changed. Your fix should work for any integer 0 to whatever this number is. So okay, let's go and test some edge cases. So if we do 0, okay, so that, it looks like it's probably working, right? Does this look like it's working? I don't know, yeah, it's saying like, oh, invalid option selected. Like that is true, we did not give it a valid option. Okay, well, what if we do like this big number right here? Okay, so it says, yeah, invalid option selected. Okay, sure. What if we now go and do 8? Okay, all right. Well, is this working as intended? Well, it kind of is, because we actually only wanted it to work for this specified input. So actually, it's totally fine to just like ignore that case. Yeah, that's fine. Okay. Sure, okay. So that is kind of the changes that are needed. Someone did mention, though, that one thing that we could do is we could probably bring like this now into our while loop. And what this will do is it will kind of clean up our code a little bit, and we can probably get rid of this. So, I mean, technically this isn't a minimal change, but could be useful. Yeah, question? Uh-huh. Oh, that'd be fine. Yeah, you wouldn't get points off for that. Yeah. Okay, cool. So now, imagine part 2 of this question. So remember, like this is the question that was given whatever last time. Now let's imagine there was an extended version of this question that you were given on your final that said, all right, go and create now a GitHub workflow for this to verify formatting and to build it and to like run it as a test. Where would you start with that? Okay, yeah. Absolutely, yeah, that's exactly what I would do. I would copy final project code, and I would bring that in, yeah. And then, yeah, you'd probably create your dot, GitHub/workflows file, sure. If you wanted to add, like maybe the question was like, oh, go and add a test case. Okay, well, how would you guys think of maybe doing a test case for this? Okay, yeah? Okay, sure. So we could try, sending 0, 1, 2, 3, 4. Okay. And how would we do that? So maybe we could do like a test script right here. And maybe we can do /debugging app or something. I don't know, something like that. So when we run this, if we were to just do this, so cd do bash, right? So notice that we still have access, we are the ones who need to type things in. So how would you modify this script now to automatically type things in for you? Because remember on GitHub Actions, you won't be able to type something in. That's the whole point of GitHub Actions, is that they happen automatically. So how do you now modify this to now take in user input? Remember? So something that you received, if you remember, for your final project was test files for Hello World 3. Hello World 3 expected a cin section, so you could maybe take a look at that. Okay. Does anyone remember what you can do? Okay, yeah? Yeah, absolutely. So we can have another dot, I don't know, we could have test.in, sure. And maybe we want to test the value, maybe just test the value 4 first, okay? So we can take this value 4. How do we send this value 4 now as cin to our app? Remember? Wait, tell the person next to you. How do you send cin? How do you send this file over cin to this? Okay, I'm seeing some good turning to the person next to you and telling them the answer. The answer would be this. Be less than. And then you can just do test.in. So there we go. So now we can run that. There you go. You can see that automatically it was passed in as the value 4. It says log user selected exit. Cool. Okay. If we now wanted to test maybe option 1, I believe we could just do this. So you can see first it says option 1 was selected, then it reopened the menu, then it exited. So yeah, what I would probably do is I would test maybe 0, I would test 1, 2, 3, 4, maybe I'd test 5, and then I would go and also test this really large number as well. So if you were asked to create a test case, then this test.sh would totally be a reasonable thing for you to create. And then maybe you could have something that's that verifies that this equals the same output as was generated. And this is something that you can grab from your final project code. You can just grab from your final project test files and create a test case exactly copied from that. And honestly, I feel that's the biggest part about being a good programmer is just creating a catalog for yourself. It's oh, I think I did this 3 years ago. Let me go back into my well-organized notes of everything, or going into my GitHub repos and pulling out that code and utilizing that. That is maybe the most important thing that differentiates a novice programmer from an experienced programmer. Just having a wealth of projects that you know are reliable and that you can go and rely on. That is crucial. I always am keeping track. If I ever learn a new thing, I'm always sure to document it very clearly so I can go back. So that is kind of, I would say, the thesis of this class, is just creating a bunch of random kind of skills that you've gained from the final project report, or final project that you've done. Yeah. Any final questions on this? Yeah.
For when
Yeah. Exactly. Yep. It would be exactly the same. Yeah. Something though that you should probably test ahead of time. Yeah. Question? Absolutely. Anything else? We good? Good. Okay. I'll see you on Friday. We'll do some more kind of final exam preparation. And yeah. Okay. See you then.